Hi and welcome to Unit 2, Topic 1, Video 6, and this is an introduction to bearings. Enjoy! Okay, so let's talk about everybody's favourite topic in maths, bearings. Let's start with a really simple diagram, which you've all seen before, I'm sure. North, east, south, and west. Now bearings are called three-figure bearings and they're often called true bearings for a reason I'll explain in a moment. But let's start with the three-figure bearings. So three-figure bearings, we start at north and go the full 360 around. North is 0, 0, 0 or 360 degrees. East is 0, 90. South is 180 and west is 270 degrees. And of course we can add a little true onto that as well. Now bearings are always measured from north and they're always measured in a clockwise direction. So a bearing is a number that denotes the direction. It gives you nothing about distance, just the direction, as a direction from north around and then back to north. So we've got to keep in mind that's always direction based. And in our true bearings we put a little tree after there because we're representing a three-figure bearing as a true bearing, based on the fact that whilst the bearing is measured as a direction, we calculate bearings using a compass by measuring our bearing to the North Pole. So that's why it's always measured from north. And when we do that, we're using a compass to measure the angle to a magnetic source. And the magnetic source is pretty close to the North Pole, but it's not at the North Pole. So that's our issue. It's really close, not at, so we have a magnetic bearing and a true bearing. And in maths, we're not going to use a compass. We're going to do the math behind it, so we're only really worried about true bearings. So you don't have to worry too much. If you see the T behind it, that's what it means. Anyway, because the bearing is measured from north around, obviously we have all of our bearings in here are 0 to 90, and then we have all of our 90 to 180 bearings, and we have all of our 180, that's not an 8, to 270 bearings, and we have all of our 270 to 360 bearings there. And so I'm going to plot some bearings now for you. Here's my first one. That is the bearing 0, 20. And if I have the bearing 0, 20 as a true bearing, that means that I can see that this is 20 degrees and this is 70 degrees. It's just the difference between 0 and 20 or 20 and 90. So it's these angles here that are really important, being able to find and use those angles. Here's another one. 150, that means that this angle is 30 and this angle is 60. Again, the difference between 150 and 180 or 150 and 90. Here's a trickier one. 221 is in this zone, but that is just 221 to 180 is 41 degrees and that is 49 degrees. So we have our bearings and we can use those to find angles, which is a really important part. So I don't want you to overcomplicate this. Plenty of people do. There are some facts that you need to know. It's measured from north in a clockwise direction. It's written as three figures and probably has a T after it. T doesn't matter. And then once you've found your bearing, you've plotted it, then you can find the angle between the bearing and east or south or whichever other main values you have. And you can use that angle and trigonometry to solve problems. So let's have a look at an example. I walk for 7 kilometres on a bearing of 136 degrees. So how do we draw this as a diagram? We'll start big, but I'll show you why we don't always have to be big. So I'm just going to note north on there, and here's this value here. And so starting at this point, this is my start, I'll call this point A. I walk for 7 kilometres on a bearing of 136. 136 is this bearing. And so this I'm going to say is my 7 kilometre walk, and I finish at B. Now it's often useful to recognise that I can have a compass point there as well with my north. That may come in handy and I'm going to keep them pretty small. But what's really important here is I recognise because I know this is 136, this bearing, I'm walking in that direction. Well, I know that this angle is 136 minus 90, which is my east. So that is 46 degrees. Or this one here, which is 44 degrees, depending on which one I use. Now, let's imagine, following this question, I've just given you information. 7 kilometres on a bearing of 136 degrees, how far east am I from where I started? So the distance east is this distance here. There's my east. And in fact, this is how far south I am from where I started, because I started at this level and I moved that far south. I've moved this far east, and I've moved 7 kilometres on a diagonal. So I can calculate these two values pretty quickly. But first what I'm going to do is I'm going to just take this diagram and just make a smaller one up here that just remove all the other nonsense. So my diagram looks like this. 7, 46, right angle, east and south. Hold on. Right angle? Where'd that come from? Well, it's important to recognise as well that this is always a right angle. So anytime I've got my north-south meeting with my east-west, it creates a right angle. And I can use that information and therefore some right angle trig. So now, let's find my length E. E is the adjacent side, 7 is the hypotenuse, so therefore we're dealing with cos. Cos of 46 is equal to E over 7, and therefore E is equal to 7 cos 46, and that's equal to 7 cos 46, 4.8626086 dot dot dot, which I'm going to write down as 4.86. And of course that's kilometres, and it's less than 7, which is what we expect. And then I can do my south as well. South there is equal to, so I get cos 46, and I don't actually get cos 46, do I? Because south is the opposite side. So I get sine 46 is equal to s over 7. So s is equal to 7 sine 46, and I can pop that in my calculator, and I get 5.03538 dot dot dot, which is 5.04 kilometres to 2 decimal places. So I can calculate distances based on bearings by just drawing a nice simple diagram. It's a really typical diagram. In the next video we'll do a couple of harder examples. Now I just want to talk about a couple other things very briefly. Firstly, if you have a bearing, let's say this one we've been dealing with, 136 degrees, true, it can be written in another way, because 136 degrees true is also, that's the angle from north. We can write it as the angle from south as well, and we can write it in the direction towards east or west, and this is another common way of seeing it. It's not as common, and it's faded a little bit, so this is where we're at, but you might see it as this. So here's my 136 degrees true, so this is 44. So we start by saying, is this bearing in the south or the north? And in this case it's in the south, so we start with the south, and then is it towards east or west? Well, it's towards east, so we have east here, and then we say, how far towards east is it? Well, it's 44 degrees towards east. You can see that there. So if I was to describe 136 degrees true as south, and then 44 degrees towards east, it would get me to the same point. I hope you can see. So that's another way of representing it, and another way of representing a true bearing that you might see. So up here, just to expand on this, this could be written as north 20 degrees east. This could be written as south 30 degrees east. And this one could be written as south 41 degrees west. Worth taking some time to just make sure that you know how that's worked out. The other thing I just wanted to mention briefly is that you have something called back bearings as well, and that language might come up. So if I've got a bearing of 136 degrees, well, to get back from point B to A, I would have to go on this bearing in the opposite direction. And this back bearing is just a rotation of 180 degrees around. So to calculate a back bearing, I just add or subtract 180 degrees. Now, I want to keep within my restricted domain, which is 0 to 360. I can write a bearing as, east is also 450 degrees, but it's just unusual to do that. So instead, we're trying to stick to the 0 to 360 range. So I get this 136, and because it's less than 180, I add 180 to that, and my back bearing is 316 degrees true. Or if it is greater than 180, I'd subtract 180 to just stay within that domain. So you've got some back bearings, we've got this way of writing bearings. This is the most important thing here, you know how to do it, and here's an example of how we might apply bearings in a simple case. So there's your introduction to bearings, or a reminder, and I'd really like you to take some time now to make sure that everything here you understood. Go back, rewatch, ask questions, most importantly. All the best. So that was our introduction to bearings. Don't forget, it doesn't have to be that hard. If you just take your time, make sure you really understand the topic and you're reviewing it regularly. All the best.